Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to look at LINQ, the language integrated query syntax that was introduced some years ago to provide a way to filter, sort, and perform other aggregate operations on collections of our data types. And so we'll demonstrate two different styles of LINQ syntax. There's a query syntax that will resemble the structured query language SQL for querying databases. So if you're already familiar with SQL, this will at least feel familiar. Then there's also a method syntax, which might feel more familiar to C# developers. However, there is one little strange nomenclature thingy that we got to figure out, okay? But I think it's pretty easy. I think I have a good way of explaining it to you, and hopefully you'll understand what it's trying to do there. But what I'd recommend is you find the code for this lesson. There should be a before and after folder, and you want to copy the code in the before folder into your projects directory and then open it up, and you'll be where I'm at right now in the Understanding LINQ project. You can see that I merely created a car class, and then I also have here a collection initialized class filled with cars, filled with attributes that we'll be able to search and sort on, and that'll give us something to work with here. All right, so what I want to do to begin with is to kind of show you a comparison between LINQ's query syntax and then LINQ's method syntax to do the exact same thing. And you'll see the obvious difference, and we'll talk about the ways in which they're different. But let's begin with a query where we want to find all BMWs in this list of cars called My Cars. So it's as easy as this, and we'll talk about the var keyword here in just a moment. But BMWs equals from car in cars, from car in my cars, where car.make is equal to BMW select car. All right. And so now let's come down here and print all those guys out. So let's go to console.write line. And let's provide the vehicle information number. So let's do 0 and 1. So we'll go, actually let's do this. Let's go for each, tab, var car in BMWs, console.write line, and then we'll go car.model and the car.vin. All right, and let's go ahead and add some of our replacement characters in there. All right, now let's go ahead and run the application, and we see that we get 3 cars that have been returned. So of all of the cars, I think there's 5 or 6. 3 of them with those VINs, A1, C3, and E5, are BMWs. And if you take a look at the data, that would be correct. So very quick, concise way of finding only those cars that match that criteria. All right, what if we wanted to add additional criteria? So say, for example, we wanted to also see where the car's year equals 2010. We could do that and rerun the application, and now we see that it just finds one of the BMWs was created in 2010. It is this last one, the 555i. All right. So that is the language integrated query syntax, the query syntax of LINQ. Let's go ahead and comment that out and compare that to the method syntax. And so here we'll go var BMWs equals my cars dot where all right, so this will give us all the BMWs. So let's go ahead and run that, and it gives us the same 3 that we got before. Now what if we wanted to also find only those where the year is equal to 2010? Then we would do that. Okay, and so you can see we found just that E5, that last one. All right, so this might take a little explanation here. For the moment, let's just ignore this last part. We'll talk about that in a moment. But what you see here, in fact, the whole thing in between the opening and closing parentheses is called a lambda expression. And you can think of it as a mini method. Essentially, what will happen is you say given P, so given an instance of the collection, only return back to me those instances of car where the make is equal to BMW. See how easy that is? Again, just a mini method. You can kind of think of this as like the input parameter, and then this is just some condition, and when it's true, then return that instance and add it into this little collection over here. So now that we have a subset of all of the available cars on our car lot. Furthermore, I just added the logical AND operator and said, and make sure also that it was in 2010. Okay, well that filters out two of them. So again, mini method, lambda expressions are just mini methods. So for any given item in the collection, it has to match that criteria, and if it does, then we can add it to this little subset collection over here that I'm calling BMWs. All right. So the var keyword, it has a very different connotation in C# than it does in other programming languages. So here I would ask that you forget what you know about var from maybe JavaScript or Visual Basic or some other programming language. It does not mean the same thing. In this case, the var keyword says that we're going to let the compiler figure out what the correct data type is. I'm not even sure what gets returned from this little query that we do here. If you were to hover your mouse cursor over the where, you can see that it's going to return back an IEnumerable of car. What's that? Not entirely sure. Doesn't really matter. I don't care what it is. I know that it is a collection of cars. And kind of to kind of prove this point, we'll talk about this in just a moment, a little bit later, where the var keyword can really come in handy because we truly don't know what it is that's being created by our LINQ queries. Okay, so again, the var keyword, it's still strongly typed. We're just going to let the compiler figure out what the type is at the point when the code is compiled. All right. All right, so let's move on and let's take a look at a few other examples. So I may want to find a list, an ordered list of cars. So I might go ordered cars equals from car in my cars, order by car.year descending select car. All right, so that's how I would take all of my cars and order them in descending order by their year. And then let's just change this from BMW. Let's put this to ordered cars like so. And this might help if we actually saw the year itself. So I'll add in car.year as well. And let's go ahead and run the application. And so you can see it starts at 2010 and in descending order works its way back to 2008. Awesome. All right, so that same query, if we were to do it in using the method syntax instead of the query syntax, it would look something like this. So var ordered cars equals my cars dot order by descending. So given each item in the collection, only return those or actually order them by the year, like so. And we should see the same grouping, and we do. Starts at 2010 and works its way back to 2008. Awesome. So again, in my opinion, this is more concise. The only conceptual hurdle you got to jump over is just make sure you understand what a lambda expression is. In this particular case, it's not a filter. We're just saying, given each item in our collection, we want to order by this particular property, the year, all right, and then add that ordered item to our collection of our new collection of cars over here. Okay. Now there's a lot of interesting things that we can do, and I'm only going to work with the method syntax from this point on. So the first we might do something like this. For example, if we wanted to find just the first item, so let's go ahead and grab this, and maybe we want to find the first item where the make is equal to BMW, like so. So this will give us the first car, the first BMW car in the list that it finds. All right, so let's go ahead and console. In fact, let's change the name of this to first BMW. So console.writeLine first BMW dot, let's go, just the VIN number should be sufficient. Let's run that. All right, so we can find that the first BMW in the list was A1, or we can do the first BMW, and we can actually start by ordering by descending given the year. So you can see I'm chaining these together. We've talked about method chaining before. This will return a collection of cars, and then this will return a single car in that collection. And then we'll print that single item's VIN out to a window, in this case E5. So the list is first sorted, and then we grab the first one that matches our criteria of BMW, okay? So that's how we can use first. I'm going to comment that out. We can also do something like this, console.writeLine, and inside of here, let's go mycars.trueForAll, and say the year is greater than 2012. And need one more right there. So is it true that all the cars in my car lot are, that every one of them is greater than 2012? That would be false, all right? Well then how about, are they all greater than at least 2009? All right, that's still false because we have at least one that was created in 2008. If we were to change this to 2007, are they all at least greater than 2007? True. All right. So that's true for all. Very helpful in order to aggregate and look across all of them and see, is this true for all the items in my list? We can also even do something interesting like this. Instead of doing this for each statement, where it's essentially what, at least 2, if not 4 lines of code, we can create a for each like so. mycars.forEach, and then inside of here, for every item, let's just do a console.writeLine. And in here, I can do p dot the VIN and p dot the sticker price. All right. And so let's go ahead and do that. In fact, we'll just do that as well. Whoops, 1 and 0. Hopefully that all makes sense. Now let's run that and see what happens. All right, so here we are. We're able to list them all out and format their values. So you see how much more compact this looks than what we were writing here. We do it all in one line of code. Again, we're passing in for every single item in our collection. Just call console.writeLine and then use that particular item's VIN and sticker price inside of our formatted string. Okay. Here's another interesting example of this. Maybe in each case we want to go so mycars.forEach. In fact, here, let's do this before that line of code. Let's keep that one, and then go mycars.forEach. And in this case, I want to perform an operation on each of the data inside of there. So I might take the sticker price and reduce it by $3,000. Actually, let's go minus equal to. So this will take the sticker price and subtract $3,000 from the sticker price of every car in my collection. So you can see now what was, if we could kind of get a comparison going here, Let's see, unfortunately not going to be very easy to do, but you can see that what was $55,000 is now $52,000. What was $35,000 is now $32,000, and so on. Okay. So again, a lot of functionality in a very small space. Let's continue on with this thought and go and do something like mycars.exists. Do we have a car in our car lot where the model is equal to the 745 Li, true or false? And here let's do a console.writeLine, and so this will either turn true or false. Yes, we have at least one item in our inventory where the model is equal to 740 Li. Great. Now here's another good aggregate function. Here, let's just do console.writeLine, and let's go mycars.sum, and here we'll say sum up all the sticker prices. Let's see what the total value of our car lot is right now. And you can see that it's about 247,000. So actually, there should probably be a better way to format that using a format code, but hopefully you get the idea. We're able to sum up a single field across all objects in our collection of cars. All right? All right, and there's so many other things that I can show you, but I don't want to overwhelm you. But I want this just to go in one ear and out the other for now. This var keyword we've looked at, and I said that we use it because we want the compiler to figure out what the data type is. Sometimes it's easy for us to figure out what the data type of something is. Sometimes it's not so easy. So to kind of illustrate this, let's do a console.writeLine, and what I want to do is call on my cars, I'm going to call the get type. In fact, all data types in .NET have this get type method declared because it is it's declared on the grandparent of all objects called system.object. It defines this method called getType, which will tell us what the type of a given object is, and we can print it to screen. So in this first case, what is mycars? Well, mycars is a generic list of the car data type. So this understanding LINQ is the namespace, and specifically though it's the car type. So we're basically saying this is a list of T, a list of car, right? So that's what's being printed out whenever we're looking at what the cars are, and that's pretty easy to see because we've defined it here. But once we perform an operation like one of these here, let's just see, ordered cars, we'll copy that again and stick it down here. And then I'm going to do console.writeLine ordered cars.getType, and it'll show us what the data type is for ordered cars. Let's go ahead and compare the two. All right, now in this case you can see that we're no longer dealing with a list of car, even though under the hood we know we're working with a list of cars. The way that it's represented in .NET is that it's actually an ordered enumerable, so an ordered list of system of the LINQ.car, understanding LINQ.car. Okay, so again, okay, that makes sense. That's an ordered version of cars. How about just a regular old where statement? So let's do that. Let's copy that and see what the data type of that is, and then do the same sort of thing here, where we're going to see what that is. Let's go ahead and run the application again. All right, here's this third one. So this second one was an ordered enumerable. Then the one where we just called the where was an enumerable plus the where list iterator. All right, so things are starting to get a little funky here, right? It might be difficult for us to be able to express this ourselves if it were not for this var keyword. And so the var keyword is essential to help us to be able to create these very complex queries and not have to worry about what the data type of it is that's returned. We know that it is a type of list. It's an enumerable list, whether it's ordered or not, and we can for each our way through it, or whatever the case might be. Now, the last thing that I want to demonstrate is I'm going to take this this first query here, and I'm going to pop it all the way to the bottom. Again, if this stuff doesn't make sense, don't worry about it too much. I wanted to go in one ear and out the other, just to kind of explain again the value of the var keyword. In this case, let's change something about this. Let's call this my new cars. All right. And here I'm not going to return cars. I'm actually going to do what's called a projection. I'm going to only take certain values, certain properties of a car, and I'm going to project them into a new data type. What's the name of the new data type? Where am I defining that data type? I'm not going to define the data type. It's an anonymous type. What's the name? I have no idea. It's anonymous. All right. So we can define types at runtime and only choose those properties that we need in the type for the moment. Why may not be obvious just yet, but I want you to understand that there is this idea of what we can do here. So in this case, let us merely let's pull out just a few things, like the car dot make and the car. Whoops, I'm sorry. This should be select new car.make, car.model. That's all we want. We're going to leave all the other attributes of car alone. We're going to only take these two values, put them into a new anonymous type. Where's the type defined? Nowhere. We just made it up off the top of our heads. And we're going to save each of those anonymous types into a new collection of anonymous types. All right. All right, so let's go console.writeLine and then take a look at new cars.getType, and let's run the application yet another time. All right, and so this time you can see that we also here have an enumerable plus where select list iterator, whatever that means. But then notice that the data type involves something called an anonymous type that has two attributes, two string attributes, which would be the make and the model. All right. And so I say all of that to say this, that whenever you're working with LINQ, there's a lot going on under the hood to make it all very easy and accessible, but it all depends on defining your types as var, which says we'll let the compiler figure out what the type is. We're not so worried about it because the data type might be so crazy that we can't even comprehend what it is. All right. So hopefully that makes sense. Just to kind of recap the things that we talked about. Talked about the difference between the query syntax and the method syntax. We looked at a number of different examples of the various LINQ extension methods that were available. We saw how we could kind of break apart an individual lambda expression to better understand that essentially we're saying each item in the collection, run this little mini method against it and return back a given item that matches that criteria. And then we looked at how to tell what the types were and what the value of the var keyword is, and then we looked at anonymous types. All right, so we covered a lot of ground. I didn't explain everything in great detail, but the key here is just to kind of look at that little formula and try to understand what it needs. Look for examples online. Make yourself a little cheat sheet, and you should be able to utilize these methods inside your own application. All right, so that wraps up LINQ. This will be the hardest thing that you have to think about today, I guarantee it. All right, so that's it. We'll see you in the next lesson. Thanks.